Hello everyone, am I audible? So we just got a update from Simplian team that the Simplian host team actually couldn't join the session because of some technical issue at their end. So that's why they could to join only 15 minutes later. So once they join as a host, then only we can start the session. So that's why we were all waiting for them. Anyway, so now they have resolved that and we can start it. So let's continue. Today I'll be showing you how to work practically with Hdfs. Right? We have understood like how to basically, I mean, we have understood the entire architecture of Hdfs in terms of storing and retrieving the data. But we also want to understand now how does it, how do we execute commands to access Hdfs through practically. As well as we discussed yesterday, we'll be doing one exercise where we'll understand how the physical blocks are getting created when you store file in the Hdfs. So the first of all, when you, as I said, when you open, I have one question. Let me just answer that. Okay, so Mary, in that case, original name node will become second standby name mode. It will go as a standby. It will not become active. Okay. Because someone has already taken that role, right? So he has to join as a standby. Both the nodes are of equal capability only, right? So what performance? I mean, if something failed, you have to do failover. So in those cases, you should not really think about performance, right? Okay, so here, as you can see, this VM, this is how it looks like basically. So the Cloudera screen will appear here. Okay, that's a desktop, and there are a lot of other icons are available, as you can see here. So once you see this screen, that means your Hadoop cluster is working fine. Now I'll show you what all processes to look for in Hadoop cluster to make sure it is up and running. So as you can see, there is one icon given here which is called Eclipse. So Eclipse is an icon through which basically you write programs. And we will do a lot of exercise on Mapreduce using Eclipse. I'll come to that, but let's not worry about that right now. Today, first of all, let us open one terminal. So I'll be opening. Let me close some already open terminals so that. Okay, so to open a terminal, if you can see here that black window, this is what you need to click on. So it will open a new terminal. Okay, in this terminal, you need to basically start writing all the steps, whichever you want to do to play with Hadoop cluster. So the first thing which we want to make sure is we want to know whether Hadoop is running fine or not. So we need to type sudo jps. Raghu, are you saying this is in your machine or? Okay, fine. All right. So yeah, when you do sudo JPS, these are the processes which are listed. Now just observe it. By the way, I'll request one thing, all of you. When I'm doing hands-on here, you don't really need to follow it up. You can just listen and understand what I'm doing here, because that is how in online training we actually, that is a practice we follow. The trainer will show you all the hands-on exercises, everything, and then the people participants are requested to basically, whenever they have time offline, they can actually rewatch the video and they can repeat those steps, right? But if you misunderstanding this concept, then it will be difficult for you to again catch it up. So in the online session, this is how we follow. So I'll be doing all the hands-on here. You need to understand, follow it, and then ask questions if you have, so that your concepts are clear in that way. So anyway, all the commands that I'm going to write are basically recorded because of the video recording. So you don't need to worry about what I'm typing and what command I'm executing. Okay, so I have executed sudo JPS. Sudo JPS will give me the list of processes where Hadoop is running. The first and the foremost thing is these are the processes which needs to be available in this list. Okay, I'll just list down them. Whatever I'm highlighting, right, these 5 processes have to be listed here. Now you know what is secondary name node, you know what is data node, you know what is name node, right? So because we understood that yesterday architectures, and because of which you can now understand what is the functionality of each one of them. No issue. If it is not running, it will not be present here. In that case, your Hadoop is not configured properly. Okay, so secondary name node, data node, and name node. These 3 processes we already understood that they will help you to do all the Hdfs operations, storing and retrieving data from Hdfs. Then you have 2 more processes, resource manager and node manager. These 2 processes will encapsulate yarn plus Mapreduce. Okay, that is why overall all these 5 processes together, I have complete Hadoop setup running. Okay, because I have Dfs, yarn, and Mapreduce, all of them are running. So this is important. So that is why you need to make sure that all these 5 processes have to be listed here. Forget about other processes which are shown here. That is not needed right now. That is because this VM has a lot of other services also installed. That is why they are showing that kind of processes. But we don't really need to worry about them. Alright? Now, apart from that, if you want to know what is the Hadoop version, you will say Hadoop space version. Okay? So that you will get to see the actual Hadoop version which is running in this cluster. So as you can see, it is Hadoop 2.6. That's the correct version, latest version which is running. And that is available in the Cloudera distribution. So the distribution version is CDH 5.4. CDH means Cloudera Hadoop. Okay, so this is how I see the Hadoop version. Now, I want to see where the Hadoop source code are running. So basically, see, when you are installing Hadoop, you also need to know like where all the important source code program jar files are available, which will be used by Hadoop internally to do all these Hdfs yarn operations, right? So for that you need to do which Hadoop. If you do which Hadoop, it will tell you the location where Hadoop is running. So if you do cat on this file, you will get the contents of this file. Okay. Now what it says, when you do which Hadoop, it says that this is the executable file which I am running on the Hadoop cluster. Okay. So it says that this is the Hadoop executable file which I am running on the Hadoop cluster. And if you open the code of this file, it will internally call execute Hadoop library from bin folder of this directory. So what has happened here? This is called soft links, right? I'm sure people who work with Linux will know what is the soft link. So basically, yeah. So actually, in Linux, let's say you have some code, whatever may be the software. Okay. Let's say this software program is installed here with some actual code which is used by them. No, Ilya Raja, which is a normal Linux command. Okay. So this is a software which is installed here. Now let's say there are some files which are available. One of the file, let's say, is which contains how to start this services. So I want to start this service. I need to go to this file and then just say shell script sh and the file name. So it will internally execute the code of this file and execute all the services for that software. This is your actual location. But what they have done is they have created under user bin Hadoop directory. So they are creating one more shell script only, not like entire software, just one shell script which is something like this. In this you have some code. Internally it will say I want to execute a code at this location. Okay. There is some code and the last line which you say execute the actual Hadoop binaries from this location. So it will internally go and point to this location and it will start this particular script. So that's how this code is running. So this is called soft links. This doesn't have actual code, it just has some small pointer through which you can start the actual code. But the reason of creating these kind of files in different locations because you can give better access control. So admin will basically give better access control to the users. They will give users access to this particular soft link path only. They will not give access to the entire Hadoop clusters as Dfs because it becomes difficult to manage later on. Okay. So of course only select few developers will have an access to do some operations on Dfs. Okay, so this is called soft link. So that all the developers cannot access this actual code, and that's why they cannot even modify anything here. That is more like a safety point of view, security point of view. But all the developers will have access to soft link. That's why everybody can directly see when you do which Hadoop, it will see that this is the file which is running. But internally it is making call to this locations file. Okay. So this is called soft link, and this is how Hadoop is, this is how you can locate the code of Hadoop. So you can go to this particular location and we'll see what has been present there. So user leave Hadoop. If I do LL, I'll get a lot of jars. As I said, all the jars, like, as you can see here, all of them are available here, basically, where you can see the code of it. Like, there are some folders also available. So this is where all the libraries and source code available which Hadoop uses internally to do all Hdfs and Mapreduce operations. So you need to go to one of the folder. I'll just show you some important jars here. So as you can see, all these are basically jars only. They are all being used internally by Hadoop framework to do Hdfs and Mapreduce operations. Along with that, some of the jars are third-party jars which Hadoop needs to execute its code. Okay, and along with that, Hadoop has also exposed some of their APIs through jars, so we can use them also, integrate them also. Okay, so these are the locations. Now let us go to one location called CD. I think I came out of that. I need to go inside that again. So if I do pwd present working directory, it will show you the path where I am inside right now. Now I need to go to etc and Hadoop. Hadoop pwd, this is the location where I am in. If I do LL, it will show me different important configuration property of Hadoop. So I will explain you some basic important properties which a developer need to know. Okay. So let us understand them. So I'll be showing you the important properties from coresite.xml. So if I open coresite.xml, by the way, VI is the editor through which you can read the contents of the file in Linux. So if you want to work with VI editor, you can read about how to play with VI editor. VI is very popular. Okay, so once you open the coresite.xml file, what happens here is there is only one property which we need to be aware of, which is fs.defaultfs, which is nothing but it is an address of the name node. Okay, as you can see, this is the address where the name node is running. Hdfs quickstart.cloudera 8020. So when you give this property, it will basically say that this is the URL where the name node is running. Okay. So quickstart.cloudera is nothing but a same local machine. It's just a machine name, this VM name automatically given by them, and port 8020. So this is the address where the name node is running. Okay. Now let us come back to another file called hdfs site.xml. In this file, there are important properties defined, like for example, dfs.replication. It defines how many times replicate should be created, right? We understood this concept. So it is basically about replications. Okay. Now dfs.replications basically if you don't really want to change the number, by default it is 3, right? So if you don't want to change the number, then you don't really need to change value here. You don't need to override the property here. If you don't define any property, by the way, in this file, that means it is taken as a default value. So right now I want to take a replication factor not as a default value, but I want to define it here, override that. That is why I have defined it as 1. Now if you notice, if the replication factor is 1, that means every block or file you are going to store, it will always be stored in the 111 machines. Okay, so that is a replication factor, and if you have 1, each block will be having only Raj, it depends actually. You need to have a sudo user permission or the root user permission to do that. As a developer, you can't modify it unless administrator has given you that root access. Okay, so all these things will be done by admin. We don't really need to do anything here. So Kishore, replication is just, each copy will be replicated for that many times, right? We have understood replication in last sessions, detailed manner. So that number of replica copies will be configured here. If you don't define that property here, that means it is taken as a default value, which is 3. But I want to create only 1 copy for my entire file data. Then I will define the replication factor as 1 here, so that it will always create only 1 copy per data blocks of that file. So if there are 3 data blocks in the file, it will only create 3 different data blocks in this file. I mean, it will not create any new replica copies because replication is 1. No, Vishal, it will be done on each and every machine. That's why you need to use something called Cloudera Manager, which will basically help you to directly push the configuration to all the machines. You don't need to go and physically open every file and change the value. Okay. Now there is another important property called dfs.block size, which is not defined here. That means it will always take the default value of the block size, which is 128 MB. Okay, in the latest Hadoop versions, as I told you, will have a block size as 128 MB. Yes, Nikhil, these files will be available with all the data node machines so that everyone knows about these configurations. When you install that, it will be available at every machine. So Nikhil, as I said, setting will have to be same across because they don't really manually go and edit the files across the machines. They actually use something called Cloudera Manager. It's an admin UI through which if they change some property in UI, it will be applied to all the files in all the machines automatically. Okay. All right. So yeah, there was another property, block size, which is not there. So default block size will be 128 MB for the latest version. Now, apart from this, there are two more important properties which we need to know, which as a developer. No, Vijay, it just says number of data node. That's it in your cluster. Since it's in a single physical machine where data node also is running in that, so that's why it is called one only. Okay. Now here, if you can see, there are two properties, dfs.name.dir and datanode.dir. These are very important properties here. I'll tell you what does it actually help you to store. Okay, so let me just draw this diagram to explain you that. This is my name node. These are all data nodes. Now, as you can see, right, name node will store all the metadata information, right? And we know that it is storing everything in memory. But periodically also it dumps it into the file called fs image and edits. We have seen that concept, right? So basically, all the metadata information from RAM will be stored in the file called fs image. Just give me 1 second. Let me open it in a different window. Yes, I was just mentioning this point, which is okay. So we know that name node is running here, data node is running here, and name node will store all the metadata in RAM. From there, it dumps it into the fs image. Okay, so here I was just mentioning that RAM data, like all the metadata, will be stored in the fs image file in the local file system of name node, along with the edit file. So where exactly? We are saying some path, but what is that path? What is the location where name node store this fs image and edit file? So that is what is present in this particular property, dfs.namenode.name.dr. So if you go to this location, you will see all the fs image and edit files getting created. I'll show you that. We'll go to that location and I'll show you that. Apart from that, data node will store the actual physical blocks. Okay. Now data node also, if we understand this, there is a file which has, let's say, two blocks. Block 1 is stored here, block 2 is stored here, and so on and so forth. So we know that there is some path under which block 1 file will be stored in the local file system of every data node. Similarly here also. So which is that location? So that is something which is basically given by dfs.datanode.dir. So this is the location where all the blocks, physical blocks of the data node will be stored. Okay. So what I will do is we will do one small practical of accessing Hdfs, and then we'll understand how to basically I mean, so what I'm saying is these are the two properties, and after that I'll show you basically. So let me not go to that problem statement right now. We'll just understand this, but I'll take you to the place where name node stores metadata and data node stores the actual block. Okay. So these are the configuration in this property. Apart from that, there are other properties like yarnsart.xml, where you configure the yarn related properties, and then there is another property called mapreduce.xml, where you configure job tracker, which is the framework of Mapreduce you are using. So yarn is what we are using, which is the latest framework. Then your job history server details, where it is running, all these details will be configured in the mapreduce.xml. Okay. So by the way, these are some important properties. Mapred side is a Mapreduce, file. So whenever you do any change in the Mapreduce, that property configuration can be added into Mapred So we are going to see those properties when we start writing Mapreduce programs. We will set those properties to programmatically also. So anyway, so let's not worry about them. So now what I will do is I'll help you to take to the location where name node and data node stores the respective information like metadata and actual blocks. Before we move forward, is everyone clear as of now? Any questions, doubts on this? So Raj, that is something that you can find from this configuration XML file. Hdfs.xml will have this entry. Manu, to answer your questions, we have done this with Hadoop. From there, we went to the location where the Hadoop is installed. And from there, we went to the location where these configuration files are available. Okay, I have pinged you the path also. All right. Okay. Now let me actually show you the location. So before I show you the location, let me open a Mozilla browser. If you click on this button, which you can see here, icon, it will open a Mozilla browser. And once it opens it, you can see there are so many important web pages which are already bookmarked by Hadoop itself. So we don't need to do anything. Just go there and just select the name node, Hdfs name node. So this is called name node UI, which contains all the information about your Hdfs. So as you can see, it says when did it start, what is the version of Hadoop it is using, all this stuff. And then there is a cluster, entire cluster summary. So if you have allocated some X amount of memory to the Okay, so I mean, what I was telling is basically this is a cluster summary which says how much space is configured for the Hdfs, how much is used, how much is remaining. All the states are mentioned here. Along with that, if you go little down, you can see how many live nodes are there, how many dead nodes are there. Since we have only one physical machine, it says one live node. Okay, and it says number of under-replicated blocks and all that stuff are present here. Along with that, if you go down to the section, it says name node storage. So it says where the image and edit file will be stored. So this is the location, or this is the physical location or a path where name node and fs image stores the data. Okay. Basically, name node stores the fs image in this path. So I will take you to this path and let us see whether fs image and edit file are getting stored here or not. So let us go inside this path. I'll go inside current directory. So as you can see, there are so many edit files are there and some fs image file are also there. Okay. Since I am using this for a long time, I have so many files. You may not see so many files. Okay, so as you can see here, FS image and edit files are stored. Now, whichever is the latest FS image, that will be considered as the latest file with the metadata. And as you can see, all the previous edit files are versioned with some different version number. And there will be a new edit which is being written currently in the edits in progress file. So all the new changes in the metadata in the metadata will be recorded in the edits in progress file. Okay. So is this clear, everyone? How to go to the metadata file? How to check where FS image and edit files are stored in name node? So Vishal, they will be available here. They will not be stored anywhere else. They will be available here, but there periodically the older files will be moved, will be deleted. All the files will not be always archived. They'll be archived only till certain purging days. After that, purging policy will remove them. It's the same, Nikhil. It's only you can see this file only in the name node. You can't see it in other machine, right? Remember, name node only stores metadata in the FS image file in the local file system of name node. No, you can do the same on other VM also, Raghu. So Nikhil, what do you mean by path? If you really want to see the path, you need to basically check this property, right? So that's what I said. Either you go to the name node page by clicking on the Hadoop and then go to the name node storage section, which will mention this path. Or if you can see here, let me open another window. So we have gone to this property files which are stored in the Hadoop cluster. So here data node or name node's property will be there where they will store their metadata. So this is the location. Okay. Is that clear? Okay. Okay. Till this point is everyone is clear? Any more questions anybody has? No, Nikhil. Username means the actual user through which you are logging in. You are executing that command in Linux. Okay. So it will change based on your user ID. Normally, don't worry, in the production cluster, you will not have even access to go to this location at all. Administrator will never give you this access as a developer. So, but in Cloudera VM, we can see all these details. Yeah, just give me 1 minute. Alright, so this is where you can see the name node metadata, which I just showed you. Then I am right now again in this location, okay? And how do you get to access this path? As we just see, we have basically gone to this configuration file hdfs.xml, and one of the properties will have this path. So that is how I reached to this location. Since data node is also installed in the same machine, so it will also write data blocks in the same machine but in a different location, right? So if you in this, if you do LL, you will get three folders: data node, name node, and secondary name node. So name node will write data in name, which we have just seen it, where it will write fs image and edit files. Data node will write all the blocks in the data directory. So let me go to data directory. If you try to go to data directory, it will say permission denied because you will not have the access of root. So you need to first log in as a root user. If I do sudo bash, it will log in as a root user, and then if you do data, yes, it is possible. Okay, there will be a current directory. Now I'll go inside some directories and then I'll explain what I'm doing. So I am inside this location. Okay. Till this point, it will tell you that where data node will store the data block information physically. But why these many folders are created? So these are all internal to Hadoop. We don't really need to worry about them. Okay. They by default always be created. So you need to just go to this particular location, and then there is a subdirectory folder created. Under that, there will be multiple subdirectories which will be created, which will hold your actual records. Alright, so basically, as I said, all these folders are nothing but a default folder which framework will always create and then copy the blocks under that. For example, BP is nothing but block pool, okay? So it will say in this machine, this is the block pool ID under which I'm going to store all the blocks. So if you do LL on this path, there will be multiple subdirectories created in my machine. So I have to go to one of the directory path. Let's still latest subdirectory 3. Now here if I do LL, I can get all the block information which is stored. So this is where you can see all the physical blocks will be stored. As you can see, this is a physical block ID. Okay, so as you can see, these are the blocks which are being basically stored here. This is the block ID. As we understood in yesterday's architecture anatomy of a write, every block will be having a name. Block is a file name, file only, and that file will have a name. Name is a unique block ID, which is given by name node. Okay. Now what I'm going to do is I'll keep this, location open, which will store your actual physical block. Then we will do one exercise. We'll be creating one file in local file system. Then we are loading that file or copying that file into Hdfs. Obviously, internally it will create some data blocks. So we will see in this where it actually stores the data blocks. So is everyone clear what we are going to do? So I'll repeat again. I will create one simple file in the local file system with some data. Then I will copy it in the Hdfs. The moment you copy the file in Hdfs, it will be internally divided into physical blocks, and those blocks will be stored in the location which we are in right now. Okay, and we'll open this block so that we'll see the contents also. So let us see whether that the block will be created if we store file in the Hdfs. Once we understand that, then it validates all our theory concept which we have learned so far. Okay, so I'll keep this window open. I'll open one more terminal where I will show you how to access Hdfs. So this is the command through which you can access Hdfs. Remember, Hdfs is a virtual file system, but it's actually a file system only, right? So that means you will have files and folders created within that. So you just give part1 root, and then under which you will basically get all the files and folders created in Hdfs, right? So you don't need to give their names here. So let me execute this command, Hadoop fs-ls root. Hello everyone, can you hear me? Yeah, okay. So as I said, I have done Hadoop fs-ls root. So it has given me lot of files and folders which are created inside a root, right? So it's just like a normal file system, even though it is virtual, but even virtual file system also you will have normal files and folders, right? Just like we browse it in our local file system. So same way you can browse it in Hdfs. You can just say ls, then let's say if I want to type some, like if I want to see the files within this folder, then you can actually just give the folder name. It will give you all the files within that folder. Okay. Now there is a file. Assume there is one file which is created. I want to read the contents of this file. By the way, how do you know which is a file and which is a directory? So you can see that the first portion of every element is D. That means it's a directory. If there is no D mentioned here, it is dash. That means it's a file. Okay. That's how you should remember. So let's say I want to basically read the contents of this file which I have stored it in Hdfs. So I want to read the contents of this file. This is how you read it. You just say in the cat. Cat will help you to read the contents of the file from Hdfs. So is it clear, everyone, how to play with Hdfs? Any doubts here? Okay, I got a couple of questions. Let me answer them one by one. Yes, Raghu, I'll explain you that point, okay? So Raghu has a question, how do you move the files from local file system in your Windows machine to this Cloudera box? It's a very valid point. So as you can see here, there is something called devices. Okay, I need to go to shared clipboard and make it bidirectional, drag and drop and make it bidirectional. Once I do that settings, then I can drag and drop directly the files to this desktop. After that, you know how to do it, right? This is how you can bring the files to the Cloudera. However, I would recommend you to use softwares like WinSCP. Okay, if you have Windows OS, then you can use WinSCP. I'll type it here. What software is that? That is called WinSCP. That is the software which will basically help you to connect to the Cloudera file system and transfer the files from local to Cloudera and all. Let me show you that software also, which I have installed here in my machine. It is very easy if you install that software. For example, this is how the screen looks like. Okay, I have one Cloudera connection. If I open that, it would basically open the terminal which connects to the Cloudera machine. Yes, Uday, that is also fine. You can also use FileZilla. All these softwares are basically file transfer softwares. So if you're comfortable with one of them, you can use that. All right. So as you can see here, this is how basically you can see the files. Now here my local file system is there. Here my home Cloudera is there. Now you can copy and paste any files and folders from here and there. All right. So is that clear, Raghu? Nitin, what import process you want me to show? Oh, okay. Yeah. This is the command I did. Like Hadoop fs-cat and give the file location. So it gave me the entire result, basically. Okay. And now if you see here, okay, the first option was Raj, this Hadoop fs-ls root. So you are basically going to see all the files and folders within this root directory. And then you can just go to ls on one folder, then it will give you files and the folders within that folder. Then you can do cat on any file. It will allow you to read the contents of that file. So Raj, are you clear? Raj, you are not dragging and dropping the file. I will show you how to drag, how to copy the file. That we have not yet executed. Yes, Nitin. Almost most of the commands you will have Hadoop FS in front, so that it will let you know that it's a Hdfs command. So does anyone else has any other questions? All right, great. So let's go. Yeah, Raghu. So if you want to understand the connection settings, I'll show you what to do. Okay. First of all, you go to your. I'll just show you the path. Then you can do it later. So basically, in your virtual box, you need to go to devices, network. Then you can just say, network settings. If you click on the network settings, it will open this kind of window. All right, where there is an option called port forwarding here. Just click on that, and then once it opens that window, you need to just click on this insert. It will open this new line where you need to give localhost 2222. That's it, and OK. That's it. So you have made it port forwarding. So if you type localhost also, it will connect to the Cloudera. Now, how do I configure it in the Winscp? It's very simple. I will basically be making a connection like this. right? I'll just say new connection or login, something new site, let's say. Give here host name as localhost. Machine is Cloudera. That means username is Cloudera, password is also Cloudera. Okay, and save it. So it will automatically logging into the that kind of Winscp window. Is that clear, guys? Okay. Vishal, this is clear, right? I think you also wanted to understand the Winscp settings. Cool. Right, let's come back. So that's how we transfer files between local file system to local Cloudera and vice versa. We also did some basic Hdfs commands to access Hdfs. By the way, I'll share one link with you. Let me just do that. I'll be pasting it here. This is a link. No, Raghu, the data folder is something I have created. You will not see that. You have to create it. So this is the link which contains all the basic Hadoop Dfs commands. Okay, so you can read about it later. By the way, let us understand. I have just accessed some file system. I'll also show you how to create a directory and all that stuff. Okay, so don't worry about it. I'll show you all these steps. Let us first actually go ahead and uh, write a new file. But before that, I want to show you. See, Hdfs, you can view it through terminal by typing all these commands, or you can browse the Hdfs through UI. So you need to go to this Hadoop Hdfs name node page, then go to the utility section, browse the file system. Okay, so this is, once you click on utilities and browse the file system, it will open again the Hdfs only. So see, through UI also you can browse all the Hdfs files and folders. You can click on any folder and any data within that folder. All this is possible. Okay. See, the scope import demo has part M files. We have actually seen that. But here, if you click on the file, it will not give you the contents. What it gives you is, these are the blocks where this file was actually divided and stored. You need to go to these blocks to read the contents about this file. So let us do that exercise. Let me create a new directory first. So how do you create a new directory? Hadoop fs-mkdir under root. Let's say I want to create a Hdfs test as one directory. Okay. Under a root directory, I'm creating one Hdfs test directory. So as you can see here, if I go to the utility section, there will be an Hdfs test directory created, which is empty right now, which doesn't have any files here. Okay. So now what we'll do is we'll do one exercise where we'll create one file in local file system. Then we'll copy that file in Hdfs under this directory, and we'll see how the blocks are getting divided for this file and what is the data which is contained in this block. So I've created a mkdir. Now I am inside this in the local file system. Okay. Home cloud era. So I will create one file. Let's say my sample file. I'll just create a sample.txt as a file, and I'll write some data here. Hi all, welcome to the Hadoop world. It's a sample file. Okay. I'm just writing some contents. So if you see, the sample file is ready. Okay. This is the file I want to store it in Hdfs. So how do I do it? How do I copy the file from local file system into Hdfs? You just say Hadoop fs-put the sample.txt, the source path and the location path is okay. I'm going to create, basically copy a sample.txt file under Hdfs test, which is a directory which I have newly created. Okay. So put is a command to copy the file from local file system into Hdfs. There is also one more command, copy from local. Both will work the same way. Alright, so this completes the copying file. Now if you want to quickly test out, I'm inside this Hdfs test. If I refresh this page, you can see there is a sample.txt file gets copied in Hdfs. Okay. So till this part, is everyone clear? Any doubts as of now? Yes, Vishal, because it is running a lot of service. It depends on how much RAM you have. If you are using 8 GB, then it will work better. So Raghu, this is what I have done. Hadoop fs-mkdir Hdfs test under root. So that's how it creates a directory. mkdir is a command. Okay. Okay. Any more doubts anybody has? This is what you wanted to know, right, Raghu? Okay. Now my sample file is available here. How do we know? See, this is a virtual path. Now, how do we know this is a virtual path? How do you prove that? So, under root directory, see, Hdfs test is available. The simple way to prove this is you should go to the local file system and type cd root. I am inside root directory. Now, if I do ll, you can see all the folders here, right? But can you see any directory name Hdfs test here? We have stored this directory under root, right? So there is no Hdfs test available here, which means it is a virtual path. It's a virtual directory. It's not a physical directory created. Okay. So we are basically what we are doing is we are going to understand where will the blocks will be created. So by the way, everyone understands what is the difference between virtual and physical file system? Why it is called virtual? Because see, these folders are not present in the actual local file system. They are just a metadata, right? Actual data will be stored in some blocks. So if you click on some sample.txt file, for example, it will tell these many blocks I have right now. Block 0 stands for one block. And it will say this is the block ID, which is basically block ID which contains your data. So what it says in sample.txt is divided into this block 1073742718. Last 4 digit is 2718. And can you tell me where will I find this block? Yes, Kishore, you have to know the file, otherwise it will be difficult. The person who comes new in the system should be also aware of the Hdfs file system structure. He doesn't need to know all the location, but there are ways through which he can get to know about them. But eventually, ideally at the normal level, yes, everyone should be aware of the file system so that they can browse the file system very well. No, I think yes, Mano. Block will be in the data node, but which location? I have shown you the block location. Remember, we went to the file or the folder location where data node stores all the blocks. So that is the location you need to go and see. Then one of the block will be created here. Remember, I told you that we will keep one window open. Okay. So this is the window. If I do LL, I will have all the blocks here, right? Kishore, I think you need to just recollect the architecture that we understand. Name node will basically store the metadata. For your real production environment basis, yes, your point is valid. You should remember where all the virtual paths you have created, so that in future, if you want to access them, you will be aware that which path contains which data. So normally in the product kind of deployment, basically people will create separate namespace for every related business data, right? So in that point, yes, you are absolutely right that you can create a namespace for the specific business function data and store it. Okay, so this is where you can see the blocks. As you can see, the block which is created for this file is here. This is the block ID, and it says in under this data node it is available. So it's the same machine. So I will go and check here. This is the block ID. Now I'll just do VI on this block ID. I want to read the contents of this block. So as you can see, it opens the contents which we have stored for the sample.txt file before we store it in the Hdfs, right? So this is where physically your data gets stored in this block. Okay, but virtually we think that it is available in the this particular location under Hdfs test under sample.txt file, correct? But physically your data is stored in this block. All right. And why there is only one block? Because the data is very small, so it's just 55 bytes of data which is stored in the block. So is everyone clear now? Clear distinction between virtual and physical file system? Any confusion, doubts anybody has? Vishal, .meta file will basically remember what is the starting and ending character of the blocks, where the block ends, all this information. Because while processing it will be useful. The same thing, Mary. That's what I answered just now. Okay. The .meta file will contain the starting and ending point of the blocks. It will make sure that this block is complete or if some data is available in some other block. All this information will be available in the .meta file. Is that clear, Mary? By the way, is everyone clear with this distinction between virtual and physical file system? Now you should have clear idea about when we talk about SDFS and when we store data, you will know that it is just a mapping path. Actually, your block will be stored in some data nodes in the local file system. Correct? That understanding should be there with everyone. Sure, Mary. Yeah, that is some practice. You can certainly do it. All right. So this is about SDFS practicals. I will also show you some more commands just to give you an idea, right, what we are doing here. So I think some people have these questions that how do you delete the data in SDFS and all that. So I'll show you that as well. So this is my SDFS, right? Let's say I want to delete some data here. So there are some multiple folders I have created. I want to delete all these folders. So how do I delete it? So we'll say something like this. Hadoop fs hyphen. No, Raj, we can't see it because it is encoded. You can't see that contents within that. Hadoop fs hyphen rm hyphen r, because you want to recursively delete the directory. Whenever you want to delete a directory, you should define this. Okay. What it does, it will delete entire directory along with the files inside that. Okay. So as it says it is deleted, if you go back, the data directory is not there. Same way, I can also do this. Okay, so all these directories will be deleted. So RM will be basically deleting the only the file. RM-R will delete the directories in a recursive order. Yes, Uday, that's absolutely right. Alright, so that's how basically you delete the data. We have understood how to create the file, create the directory. We understood how to copy the file. I will also show you how to basically bring the file, export the file from Hdfs into the local directory. For example, let's say you have created this Hdfs test file. Under that you have created sample.txt. Now what if I want to copy this sample.txt file back into the, yes Raghu, you need an admin rights. I want to copy this sample.txt file back into the local file system. So there is a command Hadoop. Let's say under I will go to one training directory, and under that let's say there are a lot of directories. I want to copy sample file here. So I'll just say Hadoop fs-get, or you can say copy to local. Both of them are same. Then you give the location, so it is sdfs test. Under that I have sample.txt file, and then I'll just say in the current directory you copy it. So from sdfs also you can copy it back to the local file system. So Nikhil, in that case also you can view the data. You can open both the files. You have to go to both the files and see the data. It will be partial, but it will be available. And if you have stored the data with some encoding enabled, then your block will have encoded data. You can see that. Okay. So if I do LL here, as you can see, sample.txt is available. So if I do vi sample.txt, your data is available. So that's how you can export the data back from HDFS to local file system. Okay. So these are the commands which will help you to play with HDFS. So this completes my entire HDFS discussion, like architecture and hands-on. So is that clear, guys, everyone? Any doubts anybody has? Let's say we have some Mapreduce programs output, you want to bring it to the local and then probably give it to some external system. So that is possible. There are many use cases like that. Yeah, Nitin, it's same, irrespective of data type. It's the same procedure. Okay. All right, guys. So that completes my SDFS session. Now, what we will do is we have come to the we have completed SDFS. Now we'll start with new topic called Mapreduce. But I think before we start that, let's take a break. We'll come back after the break and start the new session called Mapreduce. Is that fine with everyone? All right. So see you all after the break. Okay, so let's start with Mapreduce. Can everyone see my screen? Is everyone able to see my screen? Okay, thank you. All right, so for Mapreduce, let me explain you one important thing, which is Mapreduce is basically a pattern which is applied by many people in their day-to-day life. If I say these statements, you might be surprised to know, but you all have worked on Mapreduce principles many times in your day-to-day life. Okay. So what do we mean by that? So let us take an example. Before we start understanding the architecture of Mapreduce, I just wanted to show you like how does a Mapreduce look like, so that it becomes easier for us to understand it. So let's say all of us are working in a company, right, in an organization, and all of us are actually working in a team. We have managers, even you might be a manager and you have people working with you. So different things. So basically, let's say you are working in a team who has a manager and individual contributors, and you want to basically execute some projects. So let me show you this part. I have a manager and an individual contributor available here. Let's say I have a team of 2 people. And I got this project to be processed. All right. So I have 2 people team, a manager and individual contributor, and I have a project to be processed. So manager will basically first analyze this project requirement and identify that it is going to take 4 months time to complete this project. Okay. Can you hear me, everyone? Okay, no problem. So let me repeat. So basically, I have a team of 2 people, a manager and individual contributor, and a manager got a project to be worked on. So let's say manager analyze this requirements and find out that this project will be taking about 4 to 6 months of time to complete. Okay. 4 to 6 months of time is what it will take. So what manager does, he thinks that if he assigns all the work to one guy, it is going to take 4 months, right? But he will actually hire few more developers in the team. So now manager, what he does is, let's say he had 4 people, okay, in his team, and he is now trying to equally distribute the work to among all the 4 peoples, okay. So each of them are individual contributors. Your work is equally divided into 4 parts. Manager assigns this work, the 4 modules respectively to these developers, so that they can parallelly work on these 4 parts and generate the output. Okay. Now, once it gets to, once it basically gives that work to the developer, I assume all of them are having equal efficiency. So they are going to take at least 1 month time to complete these 4 parts, right? And all of them is going to generate the intermediate output file. Right? But this is not a final stage. You have processed independent module of the work, but this is, you have not processed everything at one shot. So what happens? The manager will basically ask. So this is the intermediate output generated by all the developers. Manager will ask one of the senior developer to basically merge these outputs and generate one final output file. Right, so here what's happening is intermediate output, which is done by all the developers, is being combined and integrated by one senior guy, and then he will generate the final output. This is how basically your final project is ready and deployed into the production. So this is how at a high level any project will get executed. I'm sure of course we have abstracted out so many complexities, like there is a QA team, there is a documentation team, there is a product team, lot of stuff are there. But then at a very, very high level, this is what happens, right? A manager and individual contributors, manager will try to divide the load or the entire project into that many numbers with basically it will try to divide the work between the different individual contributors. Each of them will try to work on that parallelly, generate the intermediate output, and then that module will be integrated again to generate the final project, and that can be deployed, right? So this is the pattern that we normally follow, right, in our day-to-day life scenario. So whatever I have explained is called Mapreduce, basically in Hdfs or in Hadoop cluster, you can say. So it follows a rule called divide and conquer. So map And the in-between phase where you combine the intermediate output is called shuffle and sort. Okay. So divide and conquer is a normal paradigm or pattern which is followed by Mapreduce also. I think we have taken discussion into this in the last sessions or before that session. But then high level, just understand this flow as a Mapreduce flow. You have map function, which is a divide function, reduce function, which is a conquer function, which works on the combination data. And the shuffle and sort phase is the phase which will combine intermediate output of all the map tasks and generate and give it to the reducer as an input. Okay. So did we understand this part? By the way, I'll just change the terminology. Instead of manager, I'll write it as job tracker. Instead of individual contributor, I'll write it as task tracker. And instead of file, this project, I'll write it as it's a file. It has this many blocks. So this is how you can visualize your cluster. Job tracker is running in a manager's position. Task trackers are individual contributors. The job tracker divides the Mapreduce programs into multiple map tasks. Give it to different task trackers where the block of the file which you want to process is stored. They are processing these blocks parallelly and generate intermediate output which will be combined in shuffle and sort and given it to one of the process called reducer, which may run on any of the machines. It is decided by job tracker, and then reducer will process this data and generate the final output. So at a high level, this is how Mapreduce flow works. Is it clear? Anybody has any doubt on this? All right, so let me now start explaining you the overall architecture, internal architecture. This is just a high level flow which we understood. This is how you should visualize your Hadoop cluster, by the way, from now onwards. I'll write all the processes in this Hadoop cluster so that you will remember which one is running in which machine. There is a job tracker, there is a task tracker, there is a name node, there is data node and task tracker available with every data node machine. Each data node will have, each slave machine will have data node and task tracker running. Okay, this is how you can visualize all your processes for Hdfs and Mapreduce. Okay. Now let us start understanding the architecture. For example, let's say you want to process some data. You have written a Mapreduce program. You have submitted that as a jar file. Remember one thing, whenever you want to execute a Mapreduce program, you have to create a jar file which contains the source compiled code of your Java. So let's say you have submitted this jar file in the Hadoop cluster to process a data. So first of all, your data is divided into, your file is available in Hdfs, which was, let's say, divided into two blocks, block 1 and 2. Okay, I want to process this file to generate some output using Mapreduce. So this is the command I'm going to use. Hadoop jar path Everyone can hear me? Hello, am I audible? Okay. So what I was saying is, this is the command that you need to execute, basically to execute any jar file. Okay. Your jar file will contain the Mapreduce code. So as a developer, you will just execute this command, Hadoop jar, then you give some jar path which contains your source code of your Mapreduce program. Then you'll say input path of the file which you want to process and the output path which you want to generate the output and store it. Okay, so these two locations will have to be Hdfs path. So you are saying Hadoop jar and give the jar path which is your source code location, and then run execute that on the for the input data and output data. Okay, Mary jar file is a Java concept. Any Java program when you compile, if you have to execute it, you can create a jar file, package it, and then execute it. So for Mapreduce, you have to do that, because we will be writing Mapreduce in a Java way. Is that clear? It's called Java archive. Jar means Java archive. Start pressing up your Java concepts, Mary. That's what I can say. Because it's very important that you want to learn Hadoop and you want to do more work in Hadoop. Please, I would request everyone to start brushing up the Java concepts if you don't have Java knowledge. Otherwise, you will be stuck in many places. Okay, so when you execute this command, right, what happens behind the scenes is what we are going to understand. So we will understand how entire architecture will be executed behind the scenes. We are just writing this Java code and created the jar file out of it. We already have an input file stored in Hdfs, and I want to process this file which is divided into two blocks. And then the output which this Mapreduce program is going to get generated will be stored in the output path, right? That is what we want to do. So let us understand how do we achieve it, how does it handle it internally. So let me draw the boxes here. First of all, like I'll explain you the entire architecture by drawing some important boxes. Yes, Nitin, I would recommend more Java than any other language, because Hadoop, all ecosystems are written in Java. Okay, so it's always better to brush up the Java concepts. Python is also very handy language, and if you know Python, that is also very valuable advantage. So let's say this is the entire architecture that we are going to understand. So behind this command that you are going to execute, what happens step by step to execute this entire Mapreduce program? That is what we are going to learn. Okay. So the client, see, where you can execute this command from any of this machine. The way we understood in anatomy of a write, similar thing you can do. Any of this machine you can execute, either master or slave machine, you can execute this Hadoop jar command. Okay. So that machine becomes a client. Now client, what it does, it will first check the validation of the input and output path. It will make sure whether input path exists in Hdfs or not and output path exists in Hdfs or not. Now input path is nothing but it's a path of the file which you have stored in Hdfs, right? Which you want to process. So it has to be present in Hdfs. So that is one validation which is done. And the output path is basically the location where you want to write all the output, whatever is generated from the Mapreduce program. So the output will be written into the output path. So now you tell me whether output path should be present in Hdfs or not. See, output path is a Hdfs directory. So it should not be present, right? Some of you have said it should be present. It should not be present because whenever some path is there and if you want to rewrite data in that path, what happens? It fails because it's a Hdfs. It does write once, read many times. Remember? So once you write a file in Hdfs, you can't overwrite that file. You can't change the data in that file, update or delete anything of that file. You can only delete entire file. So that's why output path should not be present. Okay, remember that. So these are the two validations which are done by client, and then client makes a call to the job tracker saying that I want a new job ID. So job tracker will basically give him a new job ID. Job client will also inform job tracker that client wants to execute a Mapreduce program. So please give me a job ID. Well, now what is the job? Every Mapreduce program which is running on a Hadoop cluster is referred as one job. Okay, and since there could be like 100 Mapreduce programs which are running parallelly in a Hadoop cluster, it could be possible that yeah. Anyway, that we will discuss after some time. But what I'm saying here is, all the jobs. Let's say there are 20 jobs which are, let's say, running in the Hadoop cluster. All the jobs you want to monitor the status. You want to make sure whether what is the progress of each job. That's why unique job ID is assigned to every job. There is a job ID which is basically given to every job. Okay. Let's say J1 is a job ID which is given by job tracker to job client for this particular Mapreduce program. Once the job client gets this information, it will basically store the data in Hdfs under some configured path. It will create a directory named job ID, and then it will put all the information. For example, what is a jar file, what is the input path, what is an output path, all the information which the client knows from this command, all of them are persisted in the Hdfs under a directory named J1. Now, what is the use of doing that? The use of doing this is, see, ultimately job tracker is the one who is going to execute it as a map, shuffle and sort and reduce kind of programs, right? But for that it needs to access the actual code, actual jar code, right, which is available in your jar path. So that is why one way is, see, job client is running in a JVM, job tracker is also running in a separate JVM in different machines. They are two Java processes. One guy can call another process using yeah. So yeah, one JVM through another JVM, I want to send this entire jar path. So it can be possible through network IO. You have to send it, and it will have to be serialized, deserialized, lot of stuff. So it improving it in fact impacts the performance. Instead of that, what if I store all these files under a common storage location, which all of the Hadoop processes can easily access it? All the Hadoop processes can access Hdfs. That is why it is storing data in Hdfs under a directory named J1, where it will copy the file called jar file, or what is the input path and output path. All this basically information is captured under the job called J1. Okay. Then job client will make a submit method call to the job tracker saying that I am done with basic checks. Now it's your job to execute this job further. So when the job is submitted to the job tracker, it will not immediately be picked up and executed. The job tracker will basically decide them which one to execute based on the round robin fashion. So for example, when the job client submits a job to job tracker is the one who needs to start executing that job. But immediately the job will not be picked up for execution. That job will be first stored in the job queue. It's a job ID which is copied in the job queue, and then there is a FIFO scheduler available in the job tracker which does this job of whoever has first arrived in this queue. That will be given priority to execute based on the resource availability. So let's say our job, which is J1, will have come first in the queue. So that is what we are going to process. Now to process this data, J1 is just a job ID, which is a string, right? Now if I want to execute actual code, then job tracker needs to know the source location. So what it does, it will go to the same location where client would have stored the jar file. So you can just use it will basically copy the entire jar file, and from there it will start generating Mapreduce, shuffle and sort phase. So this completes job submission and job initialization phase. Is everyone clear with that? I will explain you how to work with other components, but is everyone clear as of now? Any doubts anybody has? All right, fine. So that completes the job initialization phase. Now what happens? Job tracker will already know that I have to execute this job J1. It also got this jar file, which means it contains the jar code, the Java code which we have written, which has a Mapreduce code. Now job tracker will start executing these three phases: map, shuffle, sort, and reduce. The first phase is mapper phase, right? So in mapper phase, what it does, it has to create different number of map tasks. Now number of map tasks is equal to number of data blocks in the file. So assume that this file is divided into two data blocks. So it will be by default creating two map tasks. It's a thumb rule. Number of map tasks is equal to number of data blocks of the input file which you want to process. So it will create two map tasks and then assign it to the task tracker. But I have a basic question for all of you. How does job tracker know that the input file that it is going to process will have 2 blocks? Where does it get that information from? Yes, very good, Manoraj and Vishal and Nikhil. Yes, that's right. So basically, it has to go to the name node. It will basically talk to the name node, and through name node, it will get that information that this file is divided into 2 blocks, and they are stored in these four task tracker machines with the replica copies. Now, job tracker will decide that, see, this is just a replica copy that I have shown, that block 1 is stored in 3 machines because replication factor is 3. A job tracker will decide out of task tracker 1, 2, and 4 for block 1, which one to be selected. So let's assume that it is giving map task 1 and map task 2 to task tracker 1 and task tracker 2. Okay. So it is giving these 2 map tasks to these 2 machines. Now these 2 machines, this is called task assignment. After that, they will execute them in a separate JVM. Okay, they will be processing the data. This guy is processing, let's say, block 2. This guy is processing, let's say, block 1. Okay, so this map task will basically run their code in for all the data in this block. Okay, so map1 is processing this data, and also it is generating an intermediate output parallelly in this machine. Right now, meanwhile, when the map task is being executed, every task tracker will also have to report the status to the job tracker that how much percentage of map task is completed. This is called report status update. Just like, manager, individual contributor example, I showed you that a manager will assign task to developer, and developer will say, let's say I will take 1 month to complete this work. But that doesn't mean that manager will not ask any status information from the developer till 1 month. Developer has to periodically give the status update to the manager. The same thing happens here. The task tracker will, as and when they are processing map task, they are also giving status to the job tracker saying this much percentage of the map task is completed. And once they say 100% map task is completed, that means the job tracker will start the next phase, which is shuffle and sort phase. So Vishal, we can just create a jar file and store it in one local file system. Automatically, it will be put in the Hdfs by job client. So that job tracker will also go to the same location and pick up that jar file for the execution. We don't need to do anything here. We will just create a file in the local file system. Rest will be taken care by the framework itself. Okay. Yes, yes, Vishal, don't worry. From tomorrow onwards, we'll have a lot of demo session planned. So we'll be showing a lot of examples where it will be much more clear. This is an architecture, internal architecture, which is not there in your Simply Learn PPT also. So I'm just explaining you how does it happen internally. Okay, so this completes map phase. Now shuffle and sort will get started. What does it do? It will basically combine all these intermediate output files. Okay, it will combine this intermediate output file, and then this output which is combined will be sent to one of the machine, and it will store it in the temporary location, temporary folder location of one of the machine, and copy the file here in that location. in the local file system. And then job tracker will assign a reducer to that machine. The reducer will basically go and process all the data in this file and then generate the final output. That output will be written directly into this output path which you have given while executing this program. Okay. And meanwhile, when the reducer is executing, that status will also be updated to the job tracker that this much percentage of reduced task is completed. Once the reducer is 100% done, job tracker will say that inform to the job client saying that yes, the Mapreduce is 100% completed successfully. And then job tracker will do some cleanup activity where it will go and physically delete the output file from the Tasktracker machines, intermediate output file. So is everyone clear with this architecture? Any doubts here? We have understood how it works internally, okay? There are some failure scenario which I want to cover now. But before that, any questions on this? All right. So now let's talk about failures. Like when you are executing this map and reduce task, what happens if something goes wrong? So let's say you are executing this map task and this map task failed. It could be because of the logical error that you have in your code and it failed, it throws exception. So it terminates the JVM under which it is running. Immediately task tracker which is running that will send a status to the job tracker saying that this map task is failed. So what job tracker does, he will assign the same map task, okay, to the other machine where the replica copy of this block 2 available. He will assign map1 here and ask him to process this data. Even if that fails, because of your logic, if there is a programming error, of course it is likely to fail. Then again this guy send a status. Then based on that, job tracker send the third time that map task to one of the other machine where the replica copy is available. And again if it fails, it will send a signal to the job tracker. So if after 3 attempts, this is called task attempt. So for every task which is failed, automatically it is trying to attempt it to execute it one more time with some other machine where replica copy is available. And once that is successful, that means your overall job is successful. So once you are doing this of failover, basically if one of the map task is failed, it will try 3 times. After 3 times, if it is not successful, then it will mark the entire job as failed. So this is called task attempt. So every map or reduce task is attempted 3 times to re-execute even in case of failure. After that, if it fails, then irrespective of other map reduce tasks are going fine for that job or not, the entire job itself is killed. Okay, that is what happens with the map task failure. Yes, Vishal, it is possible that if their file is huge, there may be multiple reducers running on different task tracker machine. I will take one example of how to write multiple reducer as well. Okay. All right. So this completes. This is called map failure. Any doubts on this map task failure or reduce task failure? Okay. Now, after map task failure, you have one more type of failure which is called task tracker failure. For example, let's say your map task is running fine, but what if task tracker 1 itself is failed? So it cannot send a heartbeat signal to job tracker in a given 3-second time period. So once a job tracker does not receive a heartbeat signal from a task tracker, what job tracker thinks is this task tracker is dead. So all the map tasks which were assigned to task tracker 1, job tracker will assign it to task tracker. Yeah, if task tracker could not send a heartbeat signal, job tracker will basically re-execute all the map tasks which are assigned to this failed task tracker into some other task tracker where the replica copy of that task is that block is available. Okay, and that is how it basically maintains the task failures, and then this result will be considered for further processing. So in case of task failure, all the map tasks or reduced tasks which are being executed in that machine will be relaunched and re-executed in some other machine. That is how task failure are handled. And the third type of failure is job tracker failure. If the job tracker fails, that means the entire Mapreduce execution itself is failed. There is only one person who is basically coordinating the execution of every Mapreduce job. So if there are 10 Mapreduce programs which are running on your cluster, the lifecycle management of all the 10 Mapreduce programs are done by job tracker, right? So if job tracker itself is failed, then there is no one who's going to coordinate the output of all the 10 Mapreduce programs and give the result back to the client. So basically, if job tracker is failed, it becomes single point of failure, and hence all the jobs which are running on your cluster will also be automatically killed. And that is where you have YARN, where it is much more better way handled. I will explain YARN in the later sessions, but YARN will solve this problem. That's what I said, Shantanu. So in YARN, you have the availability, high availability with the standby node. In the job tracker, which is in Hadoop 1.0, it is not there. Not really, Vishal. Client is just listening. So job tracker will submit him. So there is no wait time for client. Job tracker will send him that information as a response. Okay. So these are the different types of failures available in the Mapreduce. So what we have covered is the entire execution of Mapreduce, how it happens internally, along with the failure scenario. All right. So is that clear with everyone? Any doubts? All right, everyone. So I think that's where we completed the entire Mapreduce architecture. Yes, Mary, you are absolutely right. jar file is a Mapreduce program written in Java. That's it. It is a compiled Mapreduce program, so it can be directly executed. Okay. Yeah, so we have actually just understood the architecture of Mapreduce, understood the theory portion of it. Now what we are going to do is all the different concepts of Mapreduce, we are going to understand by doing a lot of practicals. Okay, so from tomorrow session onwards, we will start programming for Mapreduce, and we will spend at least 2 sessions, full sessions on Mapreduce only, where we will be doing a lot of Mapreduce programs by understanding various concepts. So that way you people will get much more clarity about how to tackle different problems using Mapreduce. All right. At least 2.5 sessions will be just working on Mapreduce programs. and we will be covering different concepts in Mapreduce. Some of them are not part of this slides as well, but I'll be showing you that with an example so that you'll get more clarity also. Is that clear with everyone? So that's all I had for today's session. Anybody wants to ask any further questions before we close the session? Sure, Vishal. All right, in that case, thank you everyone. Have a good day, and we'll see you tomorrow at the same time. Okay, thank you everyone. Goodbye.